in diagonalize the case. Okay, so this is the topic. Okay, so if you suppose that if you suppose that any matrix say A is diagonalizable, that is there exists an invertible matrix, suppose P, and diagonal matrix, say D. So there is an invertible matrix. You have already studied this part in your linear algebra course. So, and a diagonal matrix D, and say this matrix is diagonalizable, say lambda 1, lambda 2, and say this is lambda n, and all entries are 0. So this is your diagonal matrix. Okay, says that this A equals to this is P, which is invertible matrix, then this is D, and this is P inverse. Okay, so in this case, we have, in this case, we have what is the value of exponential matrix? This is E of xa. So this can be equals to this E to the power P inverse. So this is the formula. You can derive other. Okay. So here we cannot derive this expression because already the theoretical part is much more in this course. Okay. So we have only discussed about if any matrix A can be diagonalized in the form of D, then how can we calculate what is the exponential of A? Okay. So if you are interested to how to find this relation, then we can derive this expression also. Okay, so this equals to, this means this equals to, this is a matrix P, and what is your e to the power x d, this exponential of d, and here the diagonal matrix is d is denoted by this term. So this equals to P into this e to the power x d. So this equals to simply e to the power. So each entries are here. This is e to the power, this is lambda 1x, and e to the power lambda 2x, and similarly e to the power lambda nx. So this is the formula which can be used in this, try to find this e to the power exponential of xa. This into P inverse, this into P inverse. Okay, so this is the formula. So if any matrix A can be diagnosed as in the form of A equals to P dp inverse, so then this exponential of that can be derived by this expression. Okay, so if we take an example, and if we take any matrix, say 2 cross 2 matrix, okay, so here we take 3 cross 3 matrix, suppose 6 minus 4, 13, and 3 minus 1, 9, minus 2, 2, minus 3. Suppose this is your matrix, this is matrix, then you have to find one thing. First one is what is the value of e to the power xa for that matrix A, and second one, what is the solution of this? So is to find the general solution if our system of differential equation of type d of capital Y over dx. This equals to this matrix A, of Y. Okay. So what is this then the solution of this system of linear equation when this A is represented by this matrix? And also, if we add in here some initial condition, then what is the solution of this the system of equation? So also you can solve the initial value problem of this dy over dx that equals to a of y, where the initial condition are given, that is y0. At 0 means x components are x1, x2, x3, and here 0, 0, 0. This equals to the value of that initial condition is -2. This is 1 and 4. Okay. So this is y1, y2, y3. When x1, x2, x3 are 0, then y1, y2, y3 are these values. Okay. So this is the problem. This is the problem, and you have to find what is the, first of all, how to calculate this exponential of xa. Okay. So here what can do, we can write directly, because if we diagonalize this matrix, then there is some lengthy process and time taking. So here we write directly what is the diagonalization form of that. Okay, so the matrix A is diagonalizable, that is A equals to, this is P D P inverse. इस फॉर्म में आप लिख सकते हो उसको with what is your matrix P. P जो मैट्रिक्स होगी, आप इसके आइगन वैल्यूज निकालेंगे, करस्पॉन्डिंग आइगन वैल्यूज के आप आइगन वेक्टर्स मिलेंगे, देन आइगन वेक्टर्स से फॉर्म जो मैट्रिक्स है, दैट इज योर P. Okay, so this matrix P is here -1 1. This is, you can calculate and check if this is correct or not. This is 1 -1 and 1. This is -1 2 1 and half -half, and this is 1. Okay, so this is your matrix P, and what is matrix D is D.
हेलो सर.
हाँ
सर, इस तरह के सम कितने मार्क्स कैरी करते हैं?
किसका किसका क्या
ऐसे
बोला?
टाइप का सम कितने मार्क्स कैरी करते हैं एग्जाम में?
इस तरह की प्रॉब्लम कितने मार्क्स कैरी करेंगे? ओके,
यस.
हाँ, ये डिपेंड्स ऑन द प्रॉब्लम. अगर ये 2 cos 2 की मैट्रिक्स हो, ओके, तो आपके कम मार्क्स जो होंगे. 3 cos 3 की है तो थोड़े लेंथी पोर्शन है. तो आप ये मान के चलो कि अब आपके एग्जामिनेशन जो है ना, वो ओपन बुक एग्जामिनेशन बोर्ड में है, तो हर क्वेश्चंस आपको सिर्फ 4 ही क्वेश्चंस आपको करने हैं. तो पहले क्या थी, यूनिवर्सिटी के रूल ये थे कि आपको 85 देन 14 मार्क्स के प्रॉब्लम्स होते थे, उनमें सब सेक्शंस होते थे. तो उस केस में आपकी ये प्रॉब्लम आपकी 7-8 मार्क्स की प्रॉब्लम आती थी. ओके, बट सिनेरियो अब चेंज है. अब ओपन बुक एग्जामिनेशन में हर क्वेश्चंस की मार्क्स जो है 17.5 मार्क्स के. तो इन दैट सेंस इसके मार्क्स ऑफ कोर्स थोड़े ज्यादा हो जाएंगे, अप्रॉक्स 10 मार्क्स की प्रॉब्लम हो जाएगी. ओके, तो इस वो डिपेंडिंग ऑन द कि कैसी प्रॉब्लम है. लेंदी है तो ज्यादा मार्क्स की है, छोटी है तो कम मार्क्स की, और क्या हम पूछ रहे हैं उस पर. ओके, तो आप ये मान के चलो कि मार्क्स आपके टाइम के हिसाब से सही होते हैं, और ओपन बुक एग्जामिनेशन में थोड़े से और ज्यादा ही होगा, क्योंकि आपको सब कुछ नोट्स ओपन करके ही लिखने हैं. तो उस केस में थोड़े से हम लोग प्रॉब्लम जो है वो थोड़ी सी लेंदी देते हैं. ओके, so here D is 0 to 0 and 0 0 -1. Suppose this is your diagonal matrix. Okay, so only you are interested to, if this is a matrix A, then diagonal form of that one. Okay, then what is the value of e to the power xa? So e to the power xa is equals to, you can using this formula, this becomes p e to the power xd, p inverse. So you can write this is your matrix P. What is your matrix P? Is 1 -1 1 -1 2 1 half -half and 1. This multiplied by this exponential of that. These are the eigenvalues. Okay, so this means e to the power 1x means e to the power simply x. Second one e to the power 2x, and third one e to the power -x. and all entries are 0, corresponding entries are 0. Okay, so this is your matrix e to the power xd, e to the power this into x, e to the power this into x, e to the power this into x, into p inverse. What is p inverse? P inverse, you can calculate what is the value of p inverse, then you can find
सर आवाज बहुत
what
कट
is.
रही है.
Yes, yes, क्या हुआ? Any problem?
नो सर ठीक है.
सर आवाज बहुत कट के आ रही है.
ओके, सो नेटवर्क इशू होंगे कुछ, अब उसमें आप देखें. हम फिर से रिवाइज करते हैं. दिस इज मैट्रिक्स P, दिस इज e to the power xt. e to the power xd is simply exponential of this into x, exponential of this into x, exponential of this into x. Okay, what about P inverse? So you can find what is the value of determinant of that and adjoint of that matrix, then you find P inverse. Okay, by using P inverse formula you can find easily, and here we can write directly. This is 5, 3, minus 1, and 1, 1, 0, and minus 6, minus 4, and 2. Okay, so this is your P inverse, this is P, and this. And if you multiplied all these three matrices, you can find exponential of that. And this value is equals to, this value is e to the power, if you multiply here, this equals to 5 e to the power x. So we can write here what is the answer. So here the answer is e to the power xa, that equals to this matrix, and this matrix is e5 e to the power x minus e to the power 2x minus 3 e to the power minus x, and here similarly minus 5 e to the power x plus 2 e to the power 2x plus 3 e to the power minus x. Okay, so if you multiply here, so you can find this thing. Okay, so 10 plus 5 e to the power x e to the power 2x minus 6x, and second are 3 e to the power x minus e to the power 2x minus e to the power minus x, and so on. Okay, so you can find what is the value. Okay, simply you have to multiply that, you can get exponential of this thing. Okay, so for if you calculate by using exponential of that, you can find this thing. Okay, so here you can find exponential of that. Okay, then second one, find the general solution of this thing. Okay, so you know that what is the general solution of this. So what is the general solution of this system of equation? So you know that this is the general solution is yx. We have already given in yesterday class. What is the general solution? So this is e to the power xa, and say arbitrary constant is c1, c2, and c3. So this is the general solution. Okay, and what about this initial condition are given? So in that case, when initial condition are given, then the general solution is of this system is e to the power here x minus x0, that matrix A, okay, and y0, which is your initial condition. These two formula are we have already given to you in previous class. Okay, so here we apply this and try to find what is the general solution in next page. Okay, so in next page, if this matrix exponential matrix is given, then what is the solution of that? So here no problem. Here you can write what is the general solution for case B. General solution is yx equals to e to the power xa. What is xa? Xa is here. So you simply put here and then substitute c3. So this is the general solution of this system of equation. Okay. So now we use this third one, which is given. What is the initial condition given? Okay. So here, if we put x equals to 0, this means this is your initial condition. X0 is 0. If you put x equals to 0, this is e to the power xa. And e to the power xa is this thing into y0. And what is the value of y0? Y0 is minus 2, 1, 4. What is the general solution is yx equals to, if you multiply e to the power ex, because this term is e to the power xa, it is power x exponential of that, and here this matrix into multiplied by this. So if you multiply this matrix with this column matrix, you get the solution. Okay, so next page.
हेलो
हाँ बोलिए।
ज्वाइन होना चाहते सर
ज्वाइन, ओके।
हेलो
हाँ हाँ
सर, कोई बुक सजेस्ट कर दीजिए ना ऐसे एग्जांपल सॉल्व करने के लिए।
ओके, तो रिकमेंडेड बुक्स तो हमने दिया है।
सर वो जो सिलेबस में उसमें सर ये ऐसे एग्जांपल मिल नहीं रहे हैं, वर्ड्स ढूंढने की कोशिश करें।
ओके ओके, ठीक है, हम आपको व्हाट्सएप ग्रुप पे हम दे देंगे। हम कुछ आपको असाइनमेंट्स दे देंगे, प्रॉब्लम्स की असाइनमेंट दे देंगे। ओके
हाँ सर
ठीक। सो
सर आवाज क्लियर नहीं आ रही।
आवाज तो अब
से क्लियर है
डिपेंड करती है ना कि अब नेटवर्क इशू कहाँ क्या है। तो मेरे एंड से अगर सही है, अगर किसी को भी अगर आवाज क्लियर है, दिस मीन्स कि हमारे एंड से ठीक है, और अगर सभी को क्लियर नहीं है, दिस मीन्स हमारे एंड पे प्रॉब्लम है। ओके, सो अगर किसी इंडिविजुअल की नहीं आ रही है, दिस मीन्स की प्रॉब्लम फिर उस एंड पे है। तो थोड़ा आप इसमें देखें, और ये ऑनलाइन में तो मैं स्टार्टिंग में ही कहा है कि ये थोड़ी सी प्रॉब्लम होगी, और इस तरह से आपको चलना ही है, ऐसे करना ही, क्या किया जाए।
सर क्लियर है आपकी आवाज।
ओके ओके, वही मैं कह रहा हूँ कि अगर एक भी स्टूडेंट को अगर हमारी आवाज क्लियर है, दिस मीन्स इस हमारे एंड पे कोई फॉल्ट नहीं है। ओके, और
सर
बताएं।
सर ये जो लास्ट क्वेश्चन सी वाला था उसमें a to the power x minus x naught a तो सर x naught is equal to 0, देन सर a to the power x से फिर जो डिटरमिनेंट को सॉल्व करेंगे कि बस उसी पे छोड़ देंगे?
ओके, हम कर देते हैं कि हम यहाँ कर रहे हैं द सॉल्यूशन ऑफ initial value problem is basically can write here yx that equals to e to the power x minus x naught. This is your initial condition, exponential of a, and this is y0. This is the vector. Okay, so here what is your solution is yx is equals to e to the power, here x equals to 0. What is your initial condition is this thing. What is the value of
ज्वाइन होना चाहते हैं।
this equals to minus 2 1 4. This equals to minus 2 1 and 4. Okay, so here e to the power, this is simply x, and this equals to 0, so xa, this column is equals to minus 2 1 4. Okay, so now what is e to the power exponential of a? You have already calculated, and this term is something 5 e to the power x minus e to the power 2x minus 3 to the power minus x minus 5 e to the power x plus 2 e to the power 2x plus 3 e to the power minus x, 5 e to the power x plus to the power 2x, 6 e to the power minus x, and here similar the second and third. Okay, so this is an exponential of that multiplied by this column. This is minus 1 2 4. So you have to multiply. This is 3 cross 3 matrix, and this is 3 cross 1 matrix, and this is yx means your solution is y1 y2 and y3. Okay, this thing. Okay, so what is, if you multiply here, so you get here 3 cross 1 column matrix, and that value is minus 11 e to the power x plus e to the power 2x plus 8 to the power minus x. If we increase, you have already mentioned previously. Okay, so this equals to e to the power x minus e to the power 2x minus 8 e to the power minus x, and the final solution is e to the power 2x plus 16 e to the power minus x. So this is the final solution. So this is your yx. Okay, you can say y1 y2 and y3. These are the 3 solutions of this system of initial value problem. Okay, so here you can calculate easily what is the solution of that. Okay, so second one, what is the fundamental matrix? So in next case, in next page we try to find the matrix exponential by using fundamental matrix. Okay. So in next page, the equation of matrix exponential using fundamental matrix. Okay. So in this case, if our matrix is not diagonalizable, so if in case A is not diagonalizable, so one approach to we obtain the Jordan form. So one approach to obtain matrix exponential is to use the Jordan form. Okay, but here we use another approach. That is, if we have the initial value problem and this initial value problem is we defined dy over dx that equals to a of y, where the initial condition is y0 equals to y0. Okay, and as the solution, you know that this initial value problem has solution, and that formula of that solution is yx that equals to e to the power exponential matrix, and this is y0. Say this is equation number 1. Okay, so we know that the general solution of this dy over dx that equals to ay, this of the following structure. Okay, and this is your yx. Basically, this is the linear combination of this is y1x, and so this is y2, and this is okay. So this becomes y1x, c2, y2x, c3, y3x, and cn, ynx. Okay, so where this y1, y2, and yn, these are n linearly independent particular solution Okay, so we can write this formula rewritten. So the formula can be rewritten as this formula can be rewritten as you can write this what is your yx this equals to if we this y1 y2 y these are the column vectors, so we can write here y1x y2x up to this is ynx with this in arbitrary constant. This is c the vector. Okay, and also these are also order vectors. So with c, the c is basically c1 c2 up to c. This is the column vector. Okay, so if we're using this initial condition, and the initial condition is given, initial condition is if y0 equals to y0, this means here, this is all component is means x equals to 0, this x equals to 0 means that this is what is the value of y0, y0 is y10, y20, and yn 0. Okay, so in next page, we putting the initial condition. So in next page, is the for initial value problem. For initial value problem, here we can find this constant c is determined
सर
by
प्रीवियस पेज और एक बार दिखा दीजिए ना, स्क्रीनशॉट लेना है।
ओके, प्रीवियस पेज तो हमारे पास अब नहीं आ पाएगा, तो जो स्टूडेंट लिए हों उनसे आप शेयर करा लीजिएगा। ओके
ओके ओके सर,
ओके 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 मैं थोड़ा ध्यान रखूंगा, थोड़ा सा वेट करूंगा। ओके, फॉर इनिशियल value problem, this c can be determined by the initial condition, and what is your initial condition is y1 0, y2 0 to yn 0. This of c, this equals to y0. Okay, so this implies what is your c here. So okay. So here all are vectors, so then this, because this is all are vectors. Okay, so here this implies what is c, column vector c, this equals to y10, y20, and up to this is yn 0. So here doesn't no need of this. This is because this is a column. So okay, so this is this inverse. And the c equals to this into y0, this one. Okay, so here that's the solution of the initial value problem. This is given by what is your yx. So yx equals to, so this equals to y1, y2, y3 up to yn with constant c. And what is constant c is? C is, you can find by using initial condition, you get this, what is c? C is y10, y20 up to yn 0, that inverse of this y0. Okay, so now you simply putting what is the, by using initial condition, you get the value of that c, and now you putting what is the value of c here. Okay, so this is equation number 2. And what is equation number 1? Equation number 1 is yx that equals to the power exponential of that y0. This is equation number 1. Okay, so here if we compare these two, equations, so we get, so now comparing equations first and second, so we get e to the power this xa, basically this thing, because this is yx, y0. So this value is equals to e to the power xa. Okay, so this exponential matrix, this equals to y1x, y2x to ynx, this of y10, y20, yn 0 inverse. Okay, so if we call if this mx, if we call this matrix is mx, and in this method of evaluation, evaluating this exponential matrix, so we define the matrix this mx, and that matrix is y1x, y2x up to ynx. Okay, so this plays basically an essential role for finding the exponential matrix. So this plays an exponential role, and here this e to the power xa, this equals to, if this is your, if we call this matrix is mx, so this is your mx. So what about this? So this is m at x equals to 0. So this is m0, and that matrix has inverse. So this becomes inverse. Okay. So here you know that this is what is your mx. So we call this matrix mx. This is your basically fundamental matrix. Okay, this is the fundamental matrix. So here, if we had to find the matrix exponential, so there are another approach. We have to find what is the fundamental matrix, that is mx, and then we have to find what is the value of that matrix at x equals to 0, and then finding that inverse, and then multiply both matrices, we get matrix exponential. Okay, so if we have take a problem, or before that, what is the definition of this matrix solution? Okay, then we go through to how to evaluate and how to find this fundamental matrix. Okay, so next page, next page, we define what is a fundamental matrix solution. Okay, so if you already this is suppose y1, y2, and suppose yn, these are n linearly independent solutions of the n-dimensional homogeneous linear system, and that system is dy over dx, that equals to a of y. Okay, so and we call this what is your mx. Mx is basically this n linearly independent solutions, that is this mx is y1x, y2x, y3x, and ynx. Okay, so this we call this mx, which is defined by this n linearly independent solution. This is a fundamental matrix solution. This is fundamental matrix solution of the system. Okay, so if we take a simple example, and we can already calculate this thing, and here we try to relate that with fundamental matrix. So if we have a problem which is a find matrix exponential for any matrix A, and which is given as a -7, 3, -3, -9, 5, -3, say 9, -9, -3, and 5. Okay, so this is your matrix A. and you have to find what is the matrix exponential. Or in other words, you can given the system of equation dy by dx that equals to this form of this matrix of that. Okay, and here if this form, if you have to given this matrix. Okay, so you can obtain in by using previous method. If you have given this type of system of differential equation, you find the solution. And what is the solution? Solution is something. What is the solution of that? Is something y1x, y2x, y3x. Okay, and these are some solutions. Okay, so if we look here, if we try to find the eigenvalues and then try to find what is the solution of that, so you can find here e to the power, this is 3 e to the power minus x plus something minus of, the solution of this is like C1 e to the power minus x minus C2 e to the power 2x plus C3 e to the power 2x, and so on, like this. And what is this thing here? Minus C1 e to the power minus x plus C2 e to the power 2x, and in what term is this? Y3 is C1 e to the power minus x plus C3 e to the power 2x. Okay, so these are the solution of this system of equation. So here we, if we solve this, so we first solve this dy over dx that equals to ay, and we obtain what is your solution. Solution can be written as in this form c1 e to the power minus x. If we take common, this is 3 minus 1 1. Okay, then c2 e to the power 2x. Okay, this can be written as minus 1 1 0, and c3 e to the power 2x 1 0 1. Okay, so this gives fundamental matrix solution. And what is your fundamental matrix here? So here, this is the solution of this. So this becomes a 3 independent solution. This is minus, this is to the power minus x. Okay, and second one is e to the power minus x 3. Okay, and second one is column is e to the power 2x to the power 2x and 0, and this is e to the power 2x 0 to the power 2x. This is your fundamental matrix. Okay, so अगर आप ये देखें तो सिस्टम ऑफ इक्वेशन, आपके लीनियर सिस्टम ऑफ इक्वेशन से आप सॉल्यूशंस ऐसे बनाते हैं, और इन सॉल्यूशंस के जो लीनियरली जो इंडिपेंडेंट जो सॉल्यूशंस हैं, इनकी ये जो कॉलम है, इस कॉलम को आप y1x, y2x एंड y3x, एंड दिस इज योर y1, y2, y3, और इससे जो बनी मैट्रिक्स है, दैट इज योर फंडामेंटल मैट्रिक्स. Okay, this is your mx. Then you have to find what is your m0. What is the value of m0 when you putting x equals to 0? Then you get m0, and then you multiply it by then find the m0 inverse, that matrix, and multiply it by this mx. You get e to the power xa. So one method is this thing. If we have already known what is the solution of that system of differential equation, then we can write directly what is mx. Okay, तो यहाँ पे हम अभी आपको ये दिखा रहे हैं कि अगर हमारा सिस्टम इक्वेशन जो कि हमने ऑलरेडी ये सॉल्व किया है, जिसमें हमारा सोल्यूशन ये मालूम है, उस सोल्यूशन को हम डायरेक्टली हमने फंडामेंटल मैट्रिक्स लिख ली. बट वहां हम क्या करेंगे, जहाँ पे हमें कुछ भी नहीं पता, एक मैट्रिक्स दे दी हो और हमें एक्सपोनेंशियल मैट्रिक्स हमें निकालनी हो. ठीक है, तो उसके लिए हम अभी हम सेकंड मेथड पे हम आ रहे हैं कि हमें कुछ भी नहीं मालूम उस मैट्रिक्स के बारे में, सिर्फ हमें गिवन मैट्रिक्स दिया हो और हमें मैट्रिक्स एक्सपोनेंशियल निकालनी हो, तो हम कैसे हम डायरेक्ट निकालेंगे. ओके, यहाँ पे इस एग्जांपल में हमने ये दिखाने की कोशिश कर रहे हैं कि ये सिस्टम ऑफ इक्वेशन है, y1 is defined by this thing and y2 y3 is defined by this. This system of equation can be written as in matrix form like this, देन द सोल्यूशन, अगर हम सोल्यूशन का निकाल लिया y2 y3 y3, इस सिस्टम ऑफ इक्वेशन को हम इस फॉर्म में लिख सकते हैं। इस सोल्यूशन में हमारे जो कॉलम वाले हैं, जो 3 into e to minus x, दिस इज योर y1, दिस इज योर y2, दिस इज योर y3, y1 y2 y3, ये जो मैट्रिक्स है दैट इज योर mx, and then you have to find what is the value of m0. M0 means here you putting simply x equals to 0, and you get new matrix that is m0. Then you have to find that is inverse of that, that is m0 inverse. Then m0 inverse multiplied by mx, you get e to the power xa. Okay, so in next page we discuss this thing, so we can find what is m0. So in next page, what is mx? So mx is this matrix 3 e to the power minus x minus e to the power minus x e to the power minus x. Second column is minus e to the power 2x e to the power 2x and 0, and this is e to the power 2x 0 and e to the power 2x. Okay, so here we can find what is the value of m0. So m0, here this becomes 3 minus 1 1 minus 1 1 0. This is 1 0 1. Okay, so what is exponential? That is equals to mx, this matrix, and inverse. This means you have to find the power 2x, this multiplied by 3 minus 1 1 minus 1 1 0 1 0 1. This is inverse. Okay, and then you can find what is the value of this exponential. Okay, so you solve this. Okay, so if we take a simple example and try to find what is the matrix exponential and how to find what is the fundamental matrix for that case. So here we take a matrix of order 2 cross 2, okay, because we have to find eigenvalues and eigenvector. So here we can find this matrix 2 cross 2 matrix. Okay, so for this matrix 2 cross 2 matrix, we have to solve the same problem with diagonalization case, first one. Okay, and then second we can find by using fundamental matrix, that is mx. Okay, so the same problem we can solve by two methods. Okay. So the solution, so first one we use diagonalization method. Okay, so डायमेंशन मेथड में हमें क्या करना कि हमें सॉल्व करना this what is the value of we have to find the eigenvalues basically. So this, and we obtain the eigenvalues. Okay, so eigenvalues of this system is 9 minus lambda 5 minus lambda equals to 0. Then you have to find the quadratic equation, and the roots of that equation is, so here these roots are imaginary. This is 4 plus I, this thing. What is lambda 2 is 7 minus 4i. Okay, so these are the eigenvalues. Okay, you can check that this determinant of that equals to 0. Then what is the eigenvalues? Okay, and you have to find this eigenvectors for each eigenvalues. So if we write directly what is the eigenvectors for lambda 1, so these are obtained by solving this determinant a minus what is the eigenvalues is lambda I, so this is 7 plus 4i, this with eigenvalues eigenvector b, okay, that equals to 0. Okay, so here you get here you find what is v1 and v2. There are two eigenvalues, so you get v1 is 1 by 2, basically this equals to half plus I and 1. This is the eigenvector corresponding to this. Okay, and for second eigenvalue for lambda 2, which is minus 4i, okay, you get what is your second eigenvector. This is half minus I and 1. Okay, so I know that you are already expert in how to find the eigenvalues and eigenvector. So this is to matrix. You to calculate what is eigenvalue, what is eigenvector. Okay, so here, what is the matrix P? So the matrix P is then matrix P. This matrix P is uh, constructed by this eigenvectors. This first one is v1 and v2. So this is simply your eigenvector is this is half plus I and 1, and second one is half minus I plus 1. So this is your matrix P, which constructed by eigenvectors v1 and v2. Okay, this is your matrix P, and what is your diagonal matrix D? So D is the matrix formed by the eigenvalues, and eigenvalues are lambda 1, lambda 2. So lambda 1 is this 4i, and this is 7 minus 4i. This term is 0. Okay, so this is your diagonal matrix, which is constructed by the eigenvalues lambda 1, lambda 2. This is your diagonal matrix. This is your matrix P. Okay, so you have to check that this P, D, P inverse that equals to this matrix that equals to A. So this means you can produce your matrix in the diagonal form. Okay, so here basically, okay, so in next page, so next page, what is P is basically the matrix made by eigenvectors, and what is D is made by your eigenvalues. Okay, so here you have to check what is the P, D, P inverse that equals to A. Okay, so this condition holds. Okay, so now you have to find the matrix exponential. So we have matrix exponential that equals to P e to the power xt P inverse by using that formula. And here, what is your P is a matrix which is made by eigenvectors. So this becomes 1, and here half minus I 1. This is your P. And what about your D? D is basically exponential of what is the eigenvalues? Eigenvalues are 7 plus 4i into x. Okay, and second one e to the power minus 4i into x, and these are diagonal matrix, so this becomes 0. Okay, then what is the inverse of that? You have to find the inverse of that, and the inverse of this is equals to okay, so half plus I1, half minus I1, and inverse of that. So here, if you calculate this matrix, so this becomes e to the power 7 plus 4i x 0, 0, the power 7 minus 4i x. And what is the inverse of that? If you try to find what is the inverse, so inverse is this I, and this is half I, and here 1 by 2 plus I by 4, and here half minus I by 4. Okay, so this is inverse of that matrix. Okay, and if we multiply all three matrices, you get the solution that is equal to exponential matrix of A, and that is half minus I by 4 e to the power 7 plus 4i x plus half plus I by 4 the power 7 minus 4i x. And similarly here, this is minus half I e to the power 7 plus 4i x plus half I e to the power 7 minus 4i x. This is the first column. Second column is 5 by 8 I e to the power 7 plus 4i x minus 5 by 8 7 minus exponential of 7 minus 4i x, and here half plus I by 4 e to the power 7 plus 4i and half minus I by 4 e to the power 7 minus 4i x. Okay, so if you multiply this these three matrices, you get this thing. This is your exponential of it. तो one method is कि हमने मैट्रिक्स को क्या किया, हमने डायगोनल फॉर्म में बना ली, और ये बाय यूजिंग डायगोनल मेथड यू कैन फाइंड व्हाट इज दिस थिंग. ओके, तो ये थोड़ा सा टफ है. अगर ये 2x2 मैट्रिक्स है देन नो प्रॉब्लम, बट अगर उस केस में थोड़ा सा मुश्किल हो जाती है इनवर्स फाइंड करना. बट लगभग दोनों ही उतने ही लेंदी हैं. थोड़ा सा ये जो है सेकंड मेथड थोड़ा सा प्लस पॉइंट है उसमें, थोड़ा सा आसान. ओके, सो in next page we deal same problem with fundamentals method. Okay, so and this solution is remain same. Okay, तो आप ये देख लें कि दूसरे मेथड में भी यही सोल्यूशन हमारे आने चाहिए. ओके, तो अब इतना लंबा है कि आपको कुछ आइडिया हो जाएगी. 7 + 4i समथिंग. ओके, इस टाइप की, तो आप चेक कर लें. okay. तो सेकंड मेथड में हम देखें तो इफ यू यूज method 2, which is if you're using fundamental solution. Okay, so here the fundamental solution in this method, fundamental matrix, basically fundamental matrix solution can be obtained. This can be obtained from the eigenvalues and eigenvectors. Okay, तो अगर किसी भी मैट्रिक्स में हमारा, अगर इस केस में देखें कि हमारे जो आइगन वेक्टर्स हैं, दैट इज योर v1 and v2, these are two eigen vectors, and these eigen vectors can be written as this component is 1 2 and this component is 2 2. Okay, these are your eigen vectors. This is first one is for 2 × 2 मैट्रिक्स के लिए हमने लिखा, तो दिस इज योर आइगन वेक्टर, दिस इज सेकंड आइगन वेक्टर. ओके, एंड व्हाट इज योर आइगन वैल्यूज. सो लैम्डा की जो आइगन वैल्यूज हैं दैट इज योर λ1 and λ2. यदि ये आपने किसी मैट्रिसेस के लिए आइगन वैल्यूज निकाल लिए एंड हियर आइगन वेक्टर्स, तो व्हाट इज योर फंडामेंटल मैट्रिक्स. तो हम यहाँ डायरेक्ट हम लिख देते हैं व्हाट इज योर फंडामेंटल मैट्रिक्स. फंडामेंटल मैट्रिक्स जो होगी, दिस फर्स्ट वन, दिस मल्टीप्लाइड बाय आइगन वैल्यूज λ1 x, एंड हियर दिस फर्स्ट वन e to the power λ1 x. Okay, and for second, this is your second eigen vectors by for this second eigenvalues corresponding to, so we can write here, and this is our second eigenvalues. This is your fundamental matrix. So you can write directly what is fundamental matrix. So this fundamental matrix is written if you know that what is your eigenvalues and corresponding eigenvectors. So you have to calculate eigenvalues and eigenvectors, then you can write directly what is your fundamental matrix. This is your fundamental matrix. Okay, so here in this case we can write what is our eigenvectors are. Eigenvectors are half plus I. Okay, and second eigenvector is 1 to 1 into what is e to the power λ1. λ1 is 7 plus 4i into x, and here e to the power 7 plus 4i into x. This is the first column of your fundamental matrix. Second, what is eigenvector? Second eigenvector is half minus I. E to the power second eigenvalues is 7 minus 4i x, and here eigenvector is 1 into e to the power 7 minus 4i into x. This is your fundamental matrix. You can write directly this is your fundamental matrix. So you have to find what is the value of fundamental matrix at x equals to 0. So what is the value of at x equals to 0? So what is x equals to 0? This equals to half plus I, because this is 0, this becomes 1, okay, and this is half minus I, and this is 1. So this is your fundamental matrix, and this is at value m0. So matrix exponential, this equals to, you know that this formula is fundamental matrix multiplied by this matrix inverse. So this equals to this matrix half plus I e to the power 7 plus 4ix e to the power 7 plus 4ix half minus I e to the power 7 minus 4ix e to the power 7 minus 4ix. This is your matrix mx, and here you have to find inverse of that. So multiplied by that too. Okay. So if you multiply this thing, so you can get the same solution. Okay. तो आप ये खुद से करिएगा, because 1059 हो रहे हैं, तो हम आपको फिर से रिवाइज करा दें कि
फंडामेंटल में फर्स्ट कॉलम में जो u1 के ही वेक्टर है ना,
फर्स्ट कॉलम में जो है दिस इज ये आपके आइगन वेक्टर्स है ना, v1 और v2. तो v1 के जो है, ये v1 के एलिमेंट है हमारे v12. ओके, v12. ठीक है. ये आपका जो आइगन वेक्टर है, तो फर्स्ट आइगन वेक्टर करस्पॉन्डिंग टू आइगन वेक्टर लैम्डा 1. ये क्या है सेकंड में, सेकंड आइगन वेक्टर करस्पॉन्डिंग टू दिस. ठीक है, लैम्डा 2. तो ऐसे आप बना लेंगे अपनी फंडामेंटल मैट्रिक्स. और 0 पुट कर लिया, x equals to you get m0, then you have to find this inverse of that matrix and multiply it 4, so you get e to the power x. तो ये थोड़ा सा सिंपल है, क्योंकि यहाँ पे आपको इस मैट्रिक्स की इनवर्स निकालनी है, उससे मल्टीप्लाई करना है. वहाँ पे क्या है, वहाँ पे आपको क्या करना है, वहाँ पे e की पावर x के लिए आपको क्या करना होगा कि वहाँ पे p और e to the power xt p इनवर्स. ओके, तो वहाँ पे आपको 3 मैट्रिसेस की मल्टीप्लाई करनी है. थोड़ा सा वो लेंदी है, ये थोड़ा सा उससे इजी है. तो आइगन वैल्यूज आइगन वेक्टर तो डायगोनल फॉर्म के लिए आपको निकालना ही है दोनों केसेस में. तो आप आइगन वैल्यूज आइगन वेक्टर बना लिया, अब वहां से डायरेक्ट आप फंडामेंटल मैट्रिक्स पे आ जाओ. उस केस में उधर न जाओ. अगर आपको लगता है कि नहीं हम डायगोनलाइजेशन मेथड से करना है, तो ओके, देन नो प्रॉब्लम, आप उधर से भी कर सकते हो. तो ये दोनों मेथड है, आप इसको कंप्लीट कर लेना. इसकी इनवर्स तो हमने ऑलरेडी वहां पे आपको दी है उसकी. हाँ, तो इनवर्स को आप मल्टीप्लाई कर लो, सेम सोल्यूशन है. ओके, तो आज इतना ही करते हैं, बिकॉज टाइम इज ओवर. सो नेक्स्ट हम कल जो है वो हम आपको फंडामेंटल मैट्रिक्स और उसके बेस्ड थ्योरम और कुछ आपको न्यूमेरिकल्स कराएंगे, और कुछ आइडिया देंगे कि स्केलर मल्टीप्लिकेशन और मैट्रिक्स मल्टीप्लिकेशन में कुछ चीजें थोड़ी सी डिफर करती हैं. तो क्या चीजें थोड़ा मिसकंसेप्शन है, वो चीजें हम कल थोड़ा डिस्कस करें. ओके, तो आज इतना ही करते हैं, और बाकी कल के लिए रखते हैं, क्योंकि 11 बज चुके हैं. ओके
ओके सर.
ओके,
थैंक यू सर.